Okay, so I've taken Mungewell's program again and modified it. This time, what I decided to do was give it the simple parameter read that he uses, and basically I use that to read in the ZT2, which is the catalog of all of the effects on the pedal, the current effects. Then one by one, I go in and look at the ZD2 that comes out. Then I grab the data here. I get a BMP file out, a bitmap file. Then I look in for various bits, the on-off start. I think I've covered this before. Parameters, write it out. This time I write the file name, the numSlots, which is useful. Then I added this all patches, which takes two forms. If you don't give it a total pedal and a total FX lookup, which has just come from above, well, actually the total pedals come from above. If you don't give it those parameters, then it doesn't have it and it just does normal stuff. Otherwise, it walks through the 50 patches on the pedal, 10 to 60. It pulls down the patch, uses his code that I pulled in as a PTC parse. I parse it, and then I look inside the FX that are in that are decoded in there, and I make use of the lookup tables. Let's see how we do that. So the NPI is an index into the parameters, and we assume the number of parameters is 8, and all the other details are blank. So then we look inside and we say if the FX and total pedal are not none, then somebody passed us in a lookup. So we look up the fxid and gid of this current FX in this current patch, so that they're up to 5 or so, and we offset the base, and then we go and work out how many parameters NP are in there, and this will override the NP8 above. We then look up the name, the version description, the file name, which shows us where the bitmap file is, and the number of slots. Then we walk the parameters, and again, if this index is not -1, line 747, then we come in and say, okay, get the total pedal of that index and the parameter J-1, and we use this to work out things like the explanation, the playback, the pedal, the MIDI max, etc. And then we write it out. And we finally write this to allpatches.json. So let's just use this code above. So here we can say to it, I create a temp directory, I move into it, and I run the Python upwards -r, and pants is a dummy name. At one point I'm going to work out where I need it, but at the moment I don't know. So we hit that, and it would the pedal, the B1XFour in front of me has gone into PC mode, and off it will run. Now, what I'm doing here is pulling in the state of the pedal into a JSON format that can be used in other programs. I've been playing with TK-Inter recently, which is a graphics system for, well, you can use it in Python, you can use it in most things. I used it years ago in TCL-TK. Now, the only problem with that is it has a main event loop, and that event loop is single-threaded and assumes that basically it's the only thing running. If we then try and put MIDI in the middle of this with callbacks, then that gets in the way of the event loop and they compete with each other. So what I'm trying to do is to look up how to, there's a O'Reilly book that has some design patterns where you run the main loop in one thread and the non-TK stuff in another thread. So the idea would be that I try and offload talking to the pedal in a different thread so that it can run without hitting the event loop and they fight each other. So I tried earlier, I didn't realize this was going on. It's a long time since I used TK. So I didn't realize what was going on and I got a lot of blocking in it. Or I can read this into controller, which is the other way of doing it. And so in a moment when it's finished going through all of the pedals, so what it's doing this time, it's going first step, read all the FX, parse them, parameterize them, pull out the BMP files, the bitmaps. Then it says, oh, okay, I might as well go and create a lookup table and then go and grab all the patches, yeah? So then when it loads the patches, as we said a minute ago, it says, wait a minute, do I already know about this fxid and the GID ID? If I do, I'll augment it with more information. That's it coming through now, yeah? So it's finished there. So when we look at what we've got, let's look at the BMPs. We've got an awful lot of these, yeah? Ooh. BMP, there we go. So these are the bitmap files. If we look at a given, so there'll be a JSON file if we want to look at an individual room. And you see there we've worked out the name is room, it's got a description, it's got an FX version, etc., etc., etc. We've added in the name of the bitmap file to find it, and then we have the parameters. If we look at all FX, this is a table that can be read in, a JSON that can be read in that has, and I faked up bypass because I need. What we would have done is to get a quite rich description of what's happening. So we see that the 0th patch has got 5FX, it's called sans clean. This is the fat, let me just go to it to check it out. Yeah, sans clean, and it should have a 160 comp, a base PEQ, FDB412, and a dark pre. Now this is on my pedal, your pedal will be different because this isn't a factory. So here you see I've worked out that it has got a 160. And I've worked out that it's got this 160 comp BMP. And now if I go into the parameters, then I have 30 minus 22 on the screen. But don't forget, these are not they're MIDI values rather than the actual displayed value. So I've got a ratio of 4.0 on mine, and that's currently 30 in the whatever. A knee of hard, well that's 0.1. And a volume of 80, so that one should be okay. Yeah, there we are. Now then, the FX2 I've got is called base PEQ, that's correct, and I've got 100 for a frequency. This is again non-linear. I've got 1.0 as a Q, 0.0 as a gain, 80 is a volume, so the volume should be 80. There it is. Then for FX3, I've got a Fender based by 2, and that one has got 50, 50, 50, 100 apparently. 50, 50, 50, 100, yep. And then this dark pre, when I look on my screen, I can see that I've got a page 1 of 3. So that means this must be a slot 2, a 2 slot wide. And more importantly, it seems to me that you get an underbar U in the name of the FX. So let's see if I'm there. Look, dark pre 1U, that's correct. Or it just seems to be the pattern, and slots 2. So now we've got 50, 50, 50, 50, 50, 50, 65, 0. So 50, 50, 50, 50, 50, 50, 65, 0. So this is all working quite nicely now. So we'll be able to read this stuff directly into programs. So, you know, step 1 would be pull in the state of your pedal and then basically use it in some GUI. Now, yeah, that's all I really want to say at this point. So at one point, I need to discuss with Mungewell whether, I mean, I think he said if I was doing it in C, I just fork it, which I did, and I might even be should rewrite this in C. But there are real benefits to Python. His the construct thing that he found is pretty cool, and you know I'm not using Python as efficiently as I could do. But to be fair, it's a little Raspberry Pi. It's got plenty of power to do this, and it's running quite nicely. So, you know, you saw a few minutes, and we got the state of the pedal, which we can then offload into other programs to display, and that's what I'll be on to. I mean, the alternative is I just get myself a very cheap single board Windows computer, and they're coming down in price, and plug that to the back of my touchscreen and use the ToneLib. But you know, ToneLib's a pretty cool program. But this is just for a bit of fun. Okay, thank you for watching, and bye bye.